So the context of this lesson is probabilistic inference. That's a fancy way of talking about making predictions in AI. So first of all, to set the stage, why is this important? Why do we care about making predictions in AI? If you think about it, predictions are important in human intelligence as well, and this inspires why AI also needs to make these sorts of predictions. So as an example, just write down a few of these types of predictions. Maybe all the way here to class, as you're driving your car, one prediction you had to make is, will the light stay green as you cross the intersection? What are some other predictions that you have to make in everyday life?
Will that pedestrian stop walking?
Will the pedestrian stop walking? What else?
Will the stock price go up?
What was that?
Will the stock price go up?
Will the stock price go up?
Other cars movement.
Other cars' movement?
Yeah, like change of that.
Right, so these are all predictions that we have to make in everyday life. You might not think of this so much as a prediction, these are just decisions that you're having to make subconsciously throughout the day. Similarly, we have other predictions that we want to make in AI. One example of that is actually the same question. Will the stoplight stay green? So if you think about self-driving cars, that's an emerging technology. They have to make these sorts of predictions all the time. So the predictions that you make as you're driving on the road, an AI will have to make those same decisions as is driving your self-driving car. What are some other predictions that an AI agent might need to make? So some ways that you use AI without knowing it are your phone, on the internet. Think about these sorts of agents.
So does like Google's autocomplete rule?
Yeah, autocomplete. What is the person trying to type? What else?
What about the auto route selection for the Google Map driving navigation?
Right, so choosing the route that you might prefer, so predicting the route that you might want to take when you're navigating. Right, so these are all different types of predictions of an AI agent wanting to make. Now you might notice that some of these are based off of knowledge that we might have, so things like whether the stock will go up, or what are you trying to type. But several of these are actually about interpreting sensor data. Actually, this one, these two are about sensor data, so when you're trying to type, your phone has a screen that's detecting where it is that you're touching the screen. And that's actually a sensor. It's trying to sense where your finger is, whether you actually hit the button that you meant to hit, or if you actually meant to hit some other button, and so on. We use sensor information as well. Looking at the light, is it staying green, or was it red just a second ago? We're looking at the pedestrian as they're walking across the street, trying to see what is their movement. So these are all different ways of trying to predict probability of some event occurring. Something that we need to do every day is something that AI also needs to do. So to talk more about probability, I'll raise a little bit of this. I'll get into some notation. First, we want to talk about something called a random variable. We're just going to call that x. What I mean by a random variable is not necessarily something that's completely random like a dice roll. This just means some event occurring. We don't know whether or not it's occurred. We're trying to guess the likelihood of this event happening. So in any of these cases, x might be the light is now green, or you're trying to type this certain word. So how we want to note this is P of x, probability of x occurring. That could mean probability of light equals green. we have some probability. Let's say that the light is green 1/3 of the time. We're going to say P of light equals green is 0.333, and so on. Other ways we can represent these same predictions that we've just made, probability of, let's say, you trying to type the word yes, something like that. The probability that you're trying to type the word yes out of all the other words that you could possibly be trying to type, it's going to be some really small probability that I'm not even going to guess here, 0.000 something. So something to keep in mind here is that this is not telling us whether the light is green. It's not telling us whether you are trying to type the word yes. This just tells us out of all the possible things that you could be trying to do, what is the likelihood of one of these two events, one of these random variables, being one of these values. So what do we do with that? Well, since this doesn't tell us anything certain about what's actually happening in the world, when we're trying to make predictions, we have to give ourselves some more information. And this is where multiple variables come into play. Here we're looking at the probability of one variable, probability of the light being green, probability of the word being yes. But if we consider multiple variables, things start to get a little bit more complicated. So for example, what are some ways that multiple variables can play into each other? Well, one is, if it's cold outside, what is the likelihood that it's snowing right now? So there's one example. What are some other ways that you have to consider multiple variables in everyday life? Yeah.
If it's November 15th and the grant deadline is due, is my advisor going to cancel her meeting?
Right.
Actually
November
happens.
15th and grant due. What else?
As we approach Black Friday, well, major shoppers, make a lot of discounts.
So if it's Friday, will there
Black
be a
Friday,
discount?
Black Friday.
Oh, if it's Black Friday, will there be a discount? Right. Any other examples?
If I'm hungry and it's after midnight, what is the likelihood that I will, and I want pizza, what is the likelihood that I'll find a pizza restaurant open?
Right. And write that as, if you're hungry after midnight, what is the likelihood of finding pizza? Pizza, save some space. Okay. So these are all inferences that we have to be able to make. How do we convert this into a format that we can actually calculate and use? So we use a template of sorts, which I'm going to write here. Given, can you all see if I write on the board over here? This is as long as I can do. Okay. So, okay. What is probability of blank given that we know blank? So if we can take these statements and put it into this form, we can start to formalize this a little bit more. So the first one, how do we convert this? What is the probability of canceling a meeting given that we know it's November 15th and there's a grant due? All right, let's try the next example. So for the Black Friday example, what will we put in this column?
There's a discount.
What is the probability of a discount, right? Given that we know it's Black Friday. How about the next one? What's the probability of pizza? given that we know
I'm hungry.
I'm hungry, and it's
And
after
it's
midnight.
after midnight.
Now, how we want to represent this formally is we use a statement that looks like this. So here we have the probability of one random variable being this value. When we want to consider how different variables affect the others, we write it like this. The notation being the probability of X event occurring, given that we know Y. So what this means is that if we stop guessing about the probability of Y happening, and just assume that Y is happening, that could be something like if we know that the light is green, or we know that the light was green 5 seconds ago, what is the probability that the light is green now? Something like that. So this is how we write this notation. We can convert these examples that we've just come up with into this notation. So let me give us a first example. So for this one, the probability of canceling a meeting, given that we know it's November 15th and we have a grant due, I'm going to write that as probability of meeting canceled, given that date is November 15th and grant is due. All right, let's try the next example. How might we represent this as a variable? What's that?
So the bar, so probability of discount
Mm-hmm.
given.
Probability
the
of
bar.
discount. I'm going to say discount equals true.
Given
And
Black
then
Friday is true.
Given that, yep, I'll say date equals Black Friday. Okay, let's try this last one. Probability of pizza. Say pizza equals true. Given that state is hungry and time is midnight. Right. So these are all the formalized versions, there's not much space here, the formalized versions of each of these multivariate probabilities. We call this conditional probability. That's being the probability of these variables occurring given these conditions. Those being things like the date is November 15th or it's after midnight, and so on. Now, before we wrap up, one important thing to notice is that there's a difference between conditional probability, like this, and joint probability, which would look something like this. Joint probability, we're just considering the idea that multiple variables might be true at the same time. So here we're saying, if we know these conditions, what is the probability of these variables? Whereas joint probability would just be the probability that all these things are true at the same time. Now, it might sound the same, but it's actually a little bit different. So for example, let's say that we want to think about the probability of getting an A as your grade, given that you have good class attendance, you have completed all of your homeworks, then the probability of that occurring is probably pretty high. If you go to all your classes and you complete all your homeworks, the probability of you getting a grade is pretty good. But if you think about the joint probability, the probability of someone getting a grade that's an A, and attending all classes, and completing their homework, is going to be much smaller, right? If you think about it, the probability that any student is going to attend all the classes is pretty low. It's considered that. And the probability that a student will complete all their homeworks, not that many students complete all their homeworks, so that's a pretty low probability. And on top of that, the probability that they get a grade that's an A, which is also pretty low probability.